Millions of years ago, the largest snake ever discovered roamed the earth. Scientists believe it was one of the most formidable creatures to ever exist on Earth. This is Titanoboa, a giant serpent that once dominated the rainforest for nearly 10 million years. These are the images of some of the largest reptiles on present-day Earth. Now, guess, which is closest to Titanoboa in size? How did such an enormous serpent evolve? In 2002, members of the Smithsonian Tropical Research Institute dug through layers of black rock in a coal mine in northern Colombia. They uncovered a bone. The bone did not seem extraordinary. After all, fossils appear in coal mines all the time. But when paleontologists carefully removed the surrounding soil, they paused. It appeared to be a vertebrate, and it was enormous. At first, nobody believed it belonged to a snake because it was far too large for any known modern snake. Maybe it belonged to a dinosaur, or maybe it didn't. The fossil was collected and sent for closer study. The last of what researchers would want to do is to believe that this vertebrate belonged to a snake. If it did, then the serpent would have been a formidable killing machine and would dwarf every snake on present-day Earth. The team returned to the coal mine. Soon, another giant vertebrate appeared, then another. The deeper they searched, the clearer the picture became. The team had discovered a pool of fossils of an entire population of colossal snakes. Over the course of the expedition, 186 specimens from 30 individuals were collected. Scientists compared the fossils with modern boas and anacondas. Every curve, every joint, every ridge matched the anatomy of giant constrictors. Except one thing: size. Finally, in 2009, the specimens were described as belonging to a genus of an extinct giant snake that lived during the Middle and Late Paleocene epoch, about 58 million years ago. It was named Titanoboa. Scientists were now certain that the fossils are that of an extinct large snake. But there was one more question: how large was this serpent? A team of paleontologists began a slow reconstruction. Snakes, unlike mammals, are remarkably consistent. Their bodies are long chains of similar vertebrae. If you understand one segment well, you can begin to understand the whole organism. If a modern python or boa of a certain vertebrate size corresponds to a known body length and girth, then a fossil vertebrate can be projected along the same biological ratio. After the reconstruction, the true scale of Titanoboa was revealed, and researchers were terrified. Large individuals were able to grow up to 47 feet. In mass, it was over 1,200 kilograms. The tallest active player in professional basketball is about 7 feet and 4 inches. Now, picture 6 of him, end to end, head to heel. That is roughly the conservative length of Titanoboa. This is the size of a reticulated python, compared to the largest snake on present-day Earth, the green anaconda. Now, this is the size of Titanoboa, compared to the green anaconda. Further research revealed that Titanoboa's body would have been thicker than the torso of a grown male. In fact, it may have exceeded 3 feet at its widest point, making it larger than any snake alive today. Titanoboa was not only huge, it was likely one of the most powerful snakes ever to exist, mostly because of its sheer mass. Snakes get stronger as their bodies get thicker. Titanoboa was much thicker than today's largest anacondas, so it had far more muscle and could produce much more force. Modern large constrictors like anacondas and pythons kill by wrapping coils around prey and applying pressure until blood circulation stops. Evidence suggests Titanoboa was also a constrictor. Its coils may have exerted pressure strong enough to collapse ribs and restrict breathing in large vertebrates almost instantly. Some biomechanical models suggest its constriction pressure could have been comparable to or greater than a large car pressing down on a small area of a body surface. For any animal in its ecosystem that wasn't similarly massive, this was obviously fatal. The skull of Titanoboa was another remarkable adaptation. Instead of possessing rigid jaw joints like mammals, it contained numerous movable bones connected by elastic ligaments. This kinetic skull allowed the mouth to open far wider than the diameter of its head. The lower jaws were not fused together at the chin. Instead, flexible connective tissue linked the two halves, allowing the snake to swallow enormous prey, which is several times larger than its head. The unimaginable scale of Titanoboa left many scientists asking many questions, and perhaps the most important of all, how did Titanoboa grow to such an enormous size? To get the answer, we must travel back to 58 million years ago. The Earth was not just warmer, it was a greenhouse planet. Tropical forests stretched endlessly. Oxygen-rich wetlands covered continents, and cold seasons were almost non-existent. For a cold-blooded predator, this was the equivalent of unlocking a cheat code. Modern snakes are constrained by temperature. As ectoterms, they rely on external heat sources to regulate metabolism. Today's largest snakes, like the green anaconda or reticulated python, are limited partly because their environments are not warm enough year-round to sustain extreme body mass. Muscle movements, digestion, and even basic survival slow down in cooler conditions. Heat is not just comfort for a snake, it is fuel. However, during the Paleocene epoch, the tropical regions of the Earth were significantly hotter than today, and also with minimal seasonal variation. That stability created an environment where reptiles could remain biologically fully powered year-round. No cold season meant no metabolic downtime. Growth could continue uninterrupted for long periods. In such conditions, natural selection begins to favor size in ways that are not possible in cooler climates. Larger bodies retain heat more efficiently, and larger predators can exploit a wide range of prey. Titanoboa lived in a period when massive lungfish, giant turtles, and other reptiles dominated the river systems. These were not small meals. They were high-calorie, high-fat prey items, capable of sustaining an apex predator of extraordinary proportions. Modern snakes now exist in an environment where they must balance energy intake against scarcity. However, Titanoboa lived in a world of relative surplus. When Earth was extremely warm in the Paleocene, suitable living conditions existed and Titanoboa grew massive and hunted large prey in swampy rivers. But climates are never loyal. As millions of years passed, the world began to cool, not in a sudden catastrophe, but in a gradual withdrawal. The vast tropical wetlands began to fracture. Basically, there wasn't enough consistent heat to support such a large cold-blooded predator. So instead of being defeated by another animal, Titanoboa basically lost its living conditions. As the climate cooled and its habitat disappeared, it gradually died out until it finally went extinct around 58 million years ago. In short, Titanoboa just ran out of the hot swampy world it was built for.